Okay. Day four. We're at day four. We're at day four. Okay, okay. A little sick. I should get some water. Let me get some water. I have what? 1 minute. Okay. Plenty of time. This is where I try not to knock my water onto the floor and make a huge mess. Okay, okay. That. Ooh, it's a grid. Okay, you ride the escalator, blah blah blah, decorating, blah blah. Actually, we can help with that. We're pretty sure there's a cafeteria on the other side of the back wall. If we break through the wall, you'll be able to keep moving. The rolls of paper or ats are arranged in a large grid. The forecourt can only access a roll of paper if there are fewer than 4 rolls of paper in the 8 adjacent positions. I see. If you can figure out which rolls of paper the forklift can access, he'll spend less time looking and more time breaking down the walls. For example, there are 13 rolls of paper that can be accessed by the forklift. Wait. 4 rolls of paper. One, two, three, four. Fewer than 4. 3. Only 3. How many rolls can be accessed? I mean, here we just count, right? Talking about what? 138, but still 137 squared times 8. That seems fine. Okay. So each roll. Let's see. So this is grid. That's it. And then for row in grid, for let's enumerate. Array. Oops. Row. This isn't called this character. Uh, uh, one. Can access. If can access RC. Part one, one, print, one, RC. If y is greater than 0, grid, len, grid 0, can access. PR DC in -1, -1, yeah. Oops. God, why is it so hard for me to do? Up one row, 0 columns, +1. Except there's no middle. 0, -1, 0, 1, +1, +1, +1. Okay. Equals R plus DR equal, oops, C plus DC. Oh, wait. If grid RC does not equal at false, count or adjacent count, I don't know, whatever. If n r less than r, big R, and 0 less than C less than C, oops, and grid nr and C equal at adjacent count, return fewer than 4, less than 4. Right? I think that's it. Let's just YOLO. That's not right. Oops. Okay, let's use the sample input. What did I do wrong? Oh, goodness. 71. There are 13. What? Why did I get 71? Oh, wait. There are few. If there are fewer than 4 rolls of paper, the 8 adjacent positions. This one. Why is this wrong? Oh, because we returned way too soon. Lols. Okay, let's try that. 13. 13. Oh my goodness. Indentation error. Holy. Wow. Wow. Okay. That's a much different number. Okay, that's right. Part 2. Okay. Now they'll just need help accessing as much data as they can. Once it will, it can be removed. Once it's removed, the fork might be able to access more. How many total rolls could they keep repeating this process? Or this, here is one way you could remove as many rolls as possible. if there are fewer. Does the order matter? Initial state. I mean, I feel like okay. You could probably repeat it just on the whole grid over and over again. It's a little inefficient because there are a bunch of points in the grid that don't matter. Um, so I think instead we could just keep track of where all the points are, which we should have done in the first place, because then we don't have to do this negative checking. Anyway, so let's do this slightly differently. This is all the same. Rules. And it's going to be just a set, and there it's going to be a coordinate of where everything is. I guess we can do this down here because it's part 2. And then here. If ch equals at roles dot add, and we just add them all. And then we go through, and this makes it easy to remove rather than strings. Okay. As removed. True. While as removed equals false. I see. You need to keep track of which ones you're going to remove, and then remove them in an atomic operation, and then go through again. To remove. Okay. For roll. If can remove. Well, can remove 2. Maybe we'll just do it in line. I guess this is RC. And this is still true. If NR and C, oops, in roles and we just do that. If less than 4, right? And to remove dot add C, right? And then at the end, we don't need this. Oh, we kind of, it's a little weird because we reset to remove. It's fine. Excuse me. After we've gone through all of them, then roles equals or minus equal. Does that work? Set difference. I think that works. I think it does a set difference. I think it does a set difference. To remove. And then it wants to know how many total rolls of paper can they remove if they keep repeating this process. Before count. And then part 2 is, we don't actually need this. Print. No, how many did we remove? Before count minus rolls, right? Okay, let's try the sample input again. $43. 43 can be removed. Great. Great job, everyone. All right, not too bad. Good. That means I can go to bed soon. Larry's all done. Where am I? I'm here. Holding on at 10th. Let's see. What are the timings here? Yeah, if you did it right the first time, if you had set it up right, wow, Larry's so fast. 4 minutes for both parts. I spent a lot of time on part 1. I spent 8 minutes. Yeah. You know, I shouldn't have done it this way. I should have done the set thing the first time. Because then it would have made the second part much quicker. Because I basically rewrote all my logic. Because you could do the first part like this too. Which means we can make part 1 be after the first step. So you could do something like, let's see. Part 1 equals 0. And then if part 1 equals 0, then part 1 equals, is it how many you removed? What was it? How many rolls can be, yeah. So, 2, I think. Oh. Yeah, so that works. So we can just delete this. Yeah, not too bad. 1 second. It's fine. It's probably too slow to do the whole grid twice. But who knows? I don't know. Don't care. Okay. Why does my terminal never... Okay. Send it in. Oh, look, I jumped up to 7. Hey, that's good for me. Was I faster on my timing on the second one? It's still loading. I don't understand how actually. I assume this extension asynchronously grabs data. And so it's still in the process of fetching all the data. I don't know. I don't know how it works. Am I the orange one? Points per day.